So in this course for one variable statistics, you're going to be identifying one variable data, and then you're going to be able to design experiments for gathering that data. You're also going to be able to understand the collection of data and how it's done. You're going to understand what primary and secondary data is. You're also going to be able to explain the difference between a population and a sample. You're also going to identify different types of one variable and data and represent that data in graphical forms, i.e. histograms, circle graphs, line charts. You've done that before. You're also going to be associating properties with with common distributions. Some of the key words you're going to learn are binomial distribution, interquartile range, quartiles and range. These are all important. Mean, median, and mode. That is one of the basic things that we're going to study. And we're also going to study a concept called bias, population, the concept of an outlier, things like that. So today's lesson starts with a thing called sampling techniques. The first thing that we have to start with is a thing called population. When you hear about a thing called population, we're actually talking about basically all of the individuals that are being studied, right? Or being looked at, right? Now, when you hear the term sample, we're actually talking about something that is smaller than the population. We're talking about a group within the bigger group, i.e. a subgroup of all the individuals that are selected from the bigger population, okay? Now, a good sampling technique increases the likelihood of the sample being representative of the population. And really, what we're trying to do is we're trying to say that if I have a big sample, i.e. a big subgroup of my bigger population, then we get a more representative form of the result. So a sample is more likely to be representative if it is larger and randomly chosen throughout the country or population. So when we're talking about sampling techniques, we can think of it as how we choose people for whatever survey, for whatever testing that we want to do. When you hear the concept of a simple random sample, we're talking about basically walking up to everybody, flipping a coin. If the coin is heads, basically ask them a question, or if you flip tails, don't ask them any questions for your sampling, right? So basically each person has an equal chance of being selected. So another one is a stratified random sample. That's where the population is divided into subgroups. So imagine if we broke our population, Canada, into gender, age, and ethnicity. And then what we did was in those groups, we randomly chose people to represent all of the people in Canada. We didn't go to every single one in the group, but we had some random calculation to figure out whether we're going to ask somebody or not. That is called a stratified random sample. Now, a voluntary response sample is when you're literally standing at, say, a door somewhere, and these members choose to do the survey or are given the option to avoid the survey. So you've had those things where where different companies call your house and ask you if you want to do a survey. That is what we call a voluntary survey, because you choose to either do the survey or you hang up, or you tell them kindly, don't call me again. The next type of survey is called a cluster survey. A cluster sample. Now, with our cluster sample, right, the population is divided into small blocks, right? And each contain a certain number of people. And every cluster is part of the sample. So That's it. Now, the next type we have is a convenience sample. This sample contains members of the population from which data is most easily collected. So imagine if you've done surveys with some other people, and those people always say, yeah, give me a call. I'll do any survey for you, right? That is called a convenience sample. Or you go to some place where the people have to go and do the survey in order to be part of the organization. That's called a convenience sample. Now, the last type of sample is a systematic sample. So what happens is we go and choose every nth member of the population. So maybe when you're going to different people or you're standing by waiting to take a survey, you let 5 people pass and you always take the 6th one. Let another 5 people pass, take the 6th person, and you must get that sample. Okay? And that is a systematic sample. Now, the only problem with this thing called surveys, okay? A survey is questions that you're asking for people. Questions that you're asking people, right? And a survey contains bias if the response does not reflect what everyone in the country believes or what the population believes. Now, this can be caused by an unrepresentative sample, bad questions, or poor interpretation of the results. So, unrepresentative sample, remember how we said we had all these different samples? If we go and do these samples wrong, maybe one of these samples doesn't represent the entire population, right? And then if you have bad questions that are leading in nature, i.e. are suggestive to a person, you're actually pushing your opinion on them as a surveyor, okay? And then the last thing is when you do bad calculations. That's all. When I say poor interpretation, that is poor representation of the information. Maybe you miss a couple of people. Maybe you interpret what you had asked these people wrongly. That's it. Now, just remember, an unrepresentative sample, you could also put the concept of not being big enough. So maybe you didn't go to enough people to get something that represents enough of the people in the country or group that you intend to do your survey for. So let's quickly talk about FIRD in this first example. FIRD wants to know which type of a smartphone Ontario high schools students think is the best. Okay, FIRD works at one high school and his aunt works at the other. So they each survey the students at their own school and uses the data from both schools to draw conclusions. So if I asked you, what is the population? You got to remember that population is basically Ontario high school students. So remember, at the beginning of the question, it talked about who are the people that we're looking at. We want to know the people that we're looking at are Ontario high school students. Okay. Now, the next thing they're asking about is what is the sample? So when you're talking about a sample, we're looking about the smaller group of the overall set. So remember, if you look at this problem, they say that his aunt works at one and he works at the other, and they take a survey of students at their old school. So instead of taking a survey of all the people in Ontario, what we have done is basically just looked at all the students at both schools. Now, because they didn't really think about where they were getting all the information. They basically said they're just going to their own schools. We call this technique that was used, i.e., what was the technique being used? A. We call it a cluster or convenience because if you think about it, right, all we literally did was go to our own schools rather than go and visit all the other people in the schools, right? That's it, really. So let's look at the next question here. Is this situation, this sample, representative of the overall population? And I'm going to tell you that in this case, the sample was large, but not random enough because we literally picked 2 schools and we need to get a bigger sample, right? So for us, in order to make this thing a little bit better, right, we want to choose more schools randomly. So we want to choose the schools randomly in order to make this thing better. And we want to select random students from the school, not just select all the students of one school. Selecting all the students of those 2 schools doesn't represent the people in Hastings County. It doesn't represent the people in Durham. It doesn't represent the people in Thunder Bay that are in this class. Okay? Just understand that is it. When we do these type of problems, we're looking to get people from across the population. So when we're talking about Ontario high schools, like we said at the beginning, right? We want to get people from all over the province, not just 2 specific schools, of which the 2 people that are doing the person that's doing the survey is related to one of the teachers at that other school. Okay, that's it. So for this next question, we have this problem. We're taking a look at the sampling techniques, right? So for A, the school newspaper wants to determine which candidate for president in the upcoming student council election is supported by a majority of the students. A computer is used to randomly select 20 of the students' population. So if I'm looking at this, who are the people who are the population of the entire situation? In this case, it's everyone in the school, right? Now the sample is the smaller subset of the entire group, right? And we already said that it was the 20% of students in the school. Now, when we're looking at the type of sampling technique that was being used, right, you'll notice that the computer randomly sampled people. That gives you a hint. We're going to call this a simple random sample. Because the computer is using some form of randomness to get 20% of the school. We don't know what it is, but we immediately say that it is a simple random sample. So now let's take a look at this last bit here. The last question of part A says, suppose a certain grades are unlikely to vote. For example, maybe in grade 9, maybe grade 9s and grade 12s are less likely to vote than grade 10s and 11s. Could this create problems in our sample? Let's go take a look. So if we were in a class, we would say, yes, more lower grades could affect the survey because there might be more students in the lower grades, right? And the students in the senior wouldn't be served. And the reason why that is because they're less likely to sign up, right? That's why in Canada, we do a thing called a census, which basically forces everyone in Canada to tell the government who they are, how many people live in the area, so we can allocate resources fairly through through the government. But if we don't do that, then we cannot represent the entire country nicely with respect to disseminating money throughout the population. All right, so for part B here, a light bulb manufacturer wants to determine the lifespan of a certain type of light bulb in hours, right? The light bulbs, unlike people, are all the same, okay? So the sampling technique does not need to be random. As a result, every 100th light bulb is selected until 50 light bulbs are selected for the sample. So if I want to find out what kind of population of this thing is, we have to look at the bigger sample of the light bulbs, but we can't get there because we're going to start off by picking 50 light bulbs. Now, the key is we're picking 50 light bulbs. So if I'm looking at that, so every 100th bulb is chosen, but we're picking 50 light bulbs. Okay, so we literally pick 50 light bulbs, and that is our sample. That is the subset of the bigger set, right? Now, to get to the bigger set, what we got to do is we got to times it by 100 because we do this for every 100th light bulb, right? So that means we have 50 times 100, which means there are 5,000 light bulbs in our big population. So you understand that every 100th person that we're taking is what we call a systematic sample, a systematic random sample. So every 100th person we take, right? So what kind of sampling technique was used? Yes, we just said it. We're taking every 100th bulb from our sample. Now, let's go and take a look at this last question here. Suppose the manufacturing process is not standardized. Could this cause a problem? So when you hear the word standardized, right, they're saying if it wasn't standardized, it means that you couldn't possibly get every screw exactly the same. Imagine if you bought your iPhone and you broke your iPhone and they gave you another iPhone and it was a different iPhone. Like when I say different, it was different quality. So the first iPhone is awesome, but then the second iPhone, somewhere along the line, they went and got some different part from somewhere, and that part causes the phone to break. Instead of 10 months, it breaks in 2 months. That's not a standardized process in that case, is it? So if you think about it, if it wasn't standardized, right, then you couldn't actually go into the different places where you buy all the different parts and figure out which step of the process is broken. So you couldn't find a problem in the creation by using sampling. You would literally have to inspect every step along the construction process to figure out what was causing the fault in our product. That's it. So continuing on with sampling techniques, here is our next problem. The parent council of a school wants to determine the average number of hours per week that a student spends on homework. Students in different grades have different amounts of homework. So the sampling technique must produce a sample that is representative of all the grades. As a result, random students are selected from the grade. All right. Now, if I wanted to figure out what the population is, right? Remember, we said it was parents of a certain school want to determine the student, how much time they spend on work. Now, the sample is going to be the students at the school. And why is that? It's because the parents want to find out how many hours per week students spend at homework. So that's everybody at the school that we're looking at. Not the schools, just the school. So let's continue. All right. As a result, students are selected from each grade. So random students, so there's your randomness, right? But they're selected from each grade. All right. So the key word is random. But because we pick them from every group, so because we have random and we have groups, this means it is a stratified random sample. Now, the reason why it's stratified is because we get a certain number of students from each group that we have in our thing, right? Now, what is the sample? So you have to look at the students of the population, right? Now, the sample is the basic students selected from that random sample, okay? The students selected from each grade. Make sure you make corrections to your online worksheet so it kind of makes sense. So now let's go to this part here. So would it make more sense to survey 20 students from each grade or 20% from each grade? Let's complete the table to see which one works best. So if we take 20 students from each grade, this is what we get. We get 20 students from each grade, 9, 10, 11, and 12, which gives us a total of 80 students, right? Now, let's say that I wanted to take, instead of 80, I wanted to take 20% of each student instead. So remember, to get 20, we take the number, 20%, we take the number and then times it by 20, and then we divide by 100, and we get an answer. So now, when we go and take 20% of 200, we end up with 40. When we take 20% of the grade 10s, we end up with 20. And then when we take 20% of 75, we end up with 15. When we take 20% of the 25 seniors, we end up with 5 seniors. So now let's add them all up. 40 plus 20 plus 15 plus 5 is still 80. But here is my question. Which option makes more sense? I'm going to tell you right away that the option that makes more sense is this one. Because if you think about it, right, the most people in our population are grade 9s, right? So you kind of want to make sure that more of the people, more of the random people that you're picking are coming from your grade 9 set. And then your second biggest set should be your grade 10s, your third, and then your fourth. And I think that is way more important than getting 20 from each group, because you know what? That does not actually represent or closely match the bigger population in percentages. So let's just quickly write that down. Add this to your online note, as I did not write it in the note. So if you think of it, the 20% each of each grade represents the school more, as each grade is represented proportionally in the survey. That's it. All right, last problem. All right, so for the last problem here, we have producers of Canadian Idol. So the producers of Canadian Idol want to determine which of the two remaining candidates is the fan favorite and should be next in Canadian Idol. Yes. While the producers know the number of people who watch the show, it would be very difficult to contact a representative sample of viewers. As a result, the producers decide to have all the viewers call in toll-free to vote for their favorite singer. So if you think about this next group, think about it. It's Canadian Idol. It's not necessarily watched by all of Canada, but guess what? The representative population of all of Canadian Idol is all of Canada, isn't it? So when you think about it, since it's Canadian Idol, all of Canada watches it. So that's the population. So now, what is the sample? The sample is, or the subgroup of Canada that does this are going to be the people that watch and are just simply the voters of the show. Okay? Now, when you think about this, right? People watch the show, but they don't necessarily vote, right? So the kind of sampling or getting of the data that we're looking at is what we call voluntary response. So remember, that's where you're kind of standing around and you're giving the people the option to choose to respond or not, right? Now, would I look at this and say, is this sample likely representative of the population? I'm going to tell you, if you think about it, it doesn't represent all of Canada, right? And personally, I don't watch Canadian Idol. So do you think that the result of their polling or whatever they use to figure out who the favorite singer is by phone is representative of all the people of Canada? I'm going to tell you, no, it isn't. Absolutely not, because it only represents the people that watch the show. So those are the only people it makes sense for, is it represents the subgroup of the people on the show, not all of Canada. It's a bad technique. So when you think of bias, right? Are we actually imparting our information? So this is the last bit. What sort of bias is likely to occur because of the sampling technique, right? The type of bias that we have in this case is the following. So for this one, you could think of it as the producers chose who they think are the best, right? And what about the previous singers? Maybe there were better singers that were kicked off that people wanted on the list. Now, here's the other part. There is a list when you make a phone call, right? So unless they randomly rotate the people on the list, the first person is going to be the most likely person to be always chosen, because you know what? They're the first person. Boom. I'm going to hit them. I think they're great. Right? You get me? And because they're the first, they're always going to be front and center when they're talking about who to vote for on the show. And so now let's talk about your homework for the day. You'll notice at the bottom of your worksheet that we have these questions. We're going to do 106, number 1 and 2, AB, then 4 through 9, and then question number 12. I'll have them organized on the worksheet. And then I've also produced these questions that I'd like you to try. Okay? For number 2, A and B, here are the solutions that I wanted you to be able to see for question number 2A and 2B. I'll make sure that this is on your homework solution. Okay? Take care. Bye.